Hey everybody, we're back for part 2 of basically how to design model aircraft airframe. In this one, we're going to cover, basically all the systems, or how many systems will be in your airframe. So we're using the trusted GB again. One of the things I want to stress when you're thinking about designing your airplane, you've already thought about what the airframe will be. But you also have to think about, you've got to think about your skills and capabilities and your access to equipment, lathes maybe, a 3D printer maybe, CNC maybe, a mill. You need to think about what access you have to things you might have to build yourself. You also have to think about the expense of the systems. So when you think about a GB, a lot of people think of the systems in the GB being a motor, being the ailerons, the elevator rudder, and maybe brakes. Okay, maybe brakes. But in all reality, you could fly whatever size GB you wanted to build, a half-scale GB, a 60% GB, or a 6-scale GB, all 4 channels on your radio. But you then start thinking, okay, if I got honking big servos on one on each elevator, I might want 2 channels for that. I might have 2 or 3 servos on the rudder, depending on the type of airplane. If it's aerobatic and you got a big old barn door back there, you might have 3 servos on it. And sometimes it's nice to have multiple channels go into those 3 servos so you can tweak them. You can trim them. You might have 1 on each aileron or 2 on each aileron. So however many servos you have sometimes is how many channels you use. That's the reason on a 16-channel radio, I run out of channels really quick when I have 30 servos in an airplane. But let's think about the aircraft as all systems. Let's say the airframe is a system, because it really is a system of ribs and spars and stringers, and so that's a system. Then we think about the power plant. Is it going to be gas? Is it going to be electric? Is it a 4-stroke? Maybe it's turbine. You need to think about, okay, how is the power plant going to go into the airframe? Your motor mount. One reason the GB had a short nose is this engine in real life weighed an absolutely ton of weight. So to get the CG correct, most airplanes will lengthen or shorten the nose. Some turbines you'll see a real long nose. That's because that turbine engine doesn't weigh anything. That turboprop doesn't weigh anything. So you need to, now this is if you're designing your own airplane. Okay, if you're building a GB, you already got a pretty good idea of what all of the dimensions of the airframe would be. But when you think of the power plant, most RC GBs don't have a heavy enough motor in the front so that you don't have to add ballast. I've seen some people add on 50% GBs 15 pounds of lead in the nose to get the CG right. That's incredible. Plus, in my mind, it's a horrible designed airframe because you should have designed the tail of the airplane light. And we're going to talk about that when we get further into the design of the aircraft. Excuse me. But you've thought about your airframe as a system. You thought about your power plant as a system. Then we talk about the radio, which I touched on at the beginning of this. The radio is one of the most important things you need to think about in the way that you're going to lay out all your systems. And the reason I say that is, knock on wood, I don't think I've ever crashed an airplane from my radio signal not getting to the receiver. I know people will be flying an airplane, they'll hold the radio up and say, I don't have it, I lost it. Excuse me, I should edit that out. My allergies been acting up. I apologize. So, I don't believe that. I don't think that your signal got blocked going from your transmitter to your receiver. Chances are a wire wiggle loosed or a wire shorted out, or your batteries where the voltage wasn't capable of handling all the servos and you had a brownout. I don't believe that signal loss happens hardly ever in model aircraft. I don't believe it. Knock on wood again, I have flown over 30 years now without having a radio issue. Okay? The reason is I'm meticulous and I do maintenance and I inspect everything in my airplane almost like it's a full-scale airplane. But when you're thinking about your radio, I love Futaba S-Bus because that is basically a network for the signal wire. You can run it as long as you want. A normal servo, you can run out about 14 feet, and it will run the servo. You put 2 servos on it, it pulls down the signal voltage, and the radios will get glitchy. You put 3 servos on there, and they might not even work. So if you want to do an experiment, take like a tri-harness, put it on 14 feet of servo wire, try to run the servo, and all 3 of them will probably be real glitchy or not work, but unplug one and they'll start to work, and unplug the other one and it will work. With S-Bus, you don't have to worry about that. When you use a power box system, it is made so that each of those servo runs has its own voltage. That's the reason they have so many outlets on those power boxes for servos. So if you're building a big airplane, you need to decide what radio you're going with, okay? And then how many servos you're going to need. And you need to be so meticulous in the way you run your wire. I've seen inside airplanes that have crashed and it was a rat's nest in there. And I firmly believe a wire, I build all my own servo wires. I use the Hanson Hobbies kit and build my own servo wires so I know exactly what's going on with them. But I'm telling you, the radio is one of the most important. It is the most important thing except for your airframe. I mean, the engine can quit and you can still glide. Your radio quits and it's all over. So the next thing I want to talk about as far as these systems are concerned is your landing gear. And the landing gear has been the biggest frustration for me in RC aircraft in the last 20 years. I spent basically $1,500 for the landing gear for the B-36 and they were crap and I had to rebuild them. If you're building like a Zeroli Corsair and you're going to buy like Robart gear for it, you're spot on perfect. Okay? If you're building something massive where you need custom landing gear, very few people in the world know how to build landing gear correctly because they just don't have access to the skills to do it. Once I learned to TIG weld, I know how to build any landing gear for model aircraft in the world now. Because using the thin wall 4130 chromoly steel, you can actually build struts that won't bend. You can do all kinds of cool things. And basically build them exactly like full-scale gear, but scaled down to your airplane and be very strong. But if you're going to build something custom yourself, or let's say you're going to draw like a 50% Mosquito, because de Havilland Mosquito has some pretty complicated gear. And I'm not going to go into the gear design in this video. I'm just touching on gear design right now as part of a system. But there's huge moments in the way the gear has to react. The landing gear blocks, the way they're placed into the bulkheads that capture the landing gear's forces into the airframe is paramount. You have to really, there's so much you need to on paper to draw and sketch about your landing gears before you even start drawing the airframe in AutoCAD. Because if you saw in the first video, basically we decided what you're going to build. So let's just say you're going to build a GB. In the second video, which is this video right now, we're talking about all the systems that would go in this GB. Okay, we're not even started drawing yet. We're not even in AutoCAD yet. Okay. And then we start thinking about your flying surfaces as a system. The ailerons is its system because it's got a servo with a control horn, hinges. When you get into the stuff I build, you basically build your own hinges because a lot of the smaller hinges just don't work on giant scale airplanes. So you go on the internet, you look how hinges work on a lot of full scale aircraft, you look at the way they work on like Helldivers or Dauntlesses or Corsairs, you get your kind of noggin working on it. Okay, how would I build my own hinge? Okay, so the flying surfaces are extremely important. One reason full-scale airplanes don't have flutter, and people say, well, why does a model aircraft have flutter in the elevator and the full-scale doesn't? Very few of us RC modelers actually counterbalance our flying surfaces. Full-scale airplanes will have a counterbalance somewhere in there so that they are mechanically balanced. So if you unhook all the controls, the elevator will almost stay neutral on most airplanes. Okay, I'm not saying all airplanes. I'm not sure if a Piper Cub have balanced elevators or not, but most aircraft will have a counterbalance in there. If you look in the tail of a de Havilland Mosquito, there's a massive counterbalance that comes off the rod that connects the two elevator halves. So you need to think that you want to have balanced flying surfaces. Okay. The next thing you need to think about in systems are you going to have auxiliary systems in the aircraft? An auxiliary system would be like bomb bays, it could be bomb drops, it could be canopies open and closing, it could be doors open and closing like on a C-130. I call those auxiliary systems. Okay, brakes I count as primary. Sometimes it could be considered an auxiliary system. You have to really think about that. Now keep in mind, everybody, we're still sketching our aircraft. We have not started it in AutoCAD yet. You know, sometimes I will actually take a profile picture of an airplane from the internet. I'll cut it out, like blow it up this big, cut it out, and then I'll draw little objects as the systems I'm going to place in it, and on a table I'll move them around and see where they're fit, always keeping in mind of the center of gravity. Everything you do in an airplane that's a model aircraft, you need to be constantly freaked out, paranoid, and aware that I've got to keep my CG at the front of my design. If you design a really tail-heavy airplane and put a boatload of weight in the nose, you now have a heavier wing load than you needed. There are some programs out there that you can basically draw your airplane, well, not draw your airplane, put in all of the data moments of your airplane's weight, and it will tell you what your center of gravity is going to be, or at least what your weight is. I can't remember the name of them. I'll try to put it in this video if I can find it. But I've used it a couple of times, but to tell you the truth, I've built so many airframes now, I just kind of know what looks like it's going to be right. So here's some thoughts about center of gravity. If you're building a giant scale GB, you know you want the entire airframe in the tail to basically be balsa wood. If you need more strength, add a little bit of carbon fiber toe to it. Too many people put hardwoods and I mean, spruce is even heavy for a model aircraft in the tail. Okay? If you look at my MSL2, I don't believe there's a single piece of plywood in the tail of that airplane except the mount for the tail gear. Everything else in the airplane is balsa wood and carbon fiber toe or a carbon fiber tube as the spar and the horizontal stabilizer. So on a GB, you would want all the stringers and everything in it to basically be balsa wood, even on a half scale. Okay? You would want pull on the rudder. You don't want to put servos and all that back there because that's just adding weight to the tail. You most likely have to put the servos in the tail for the elevators. I know they're expensive, but buy the highest torque servos you can so you only have one servo per elevator half. If you got to put 2 or 3 servos back there, you're adding weight. One high torque servo does feel heavy in your hand, but it weighs less than 2 servos. Okay? Your rudder should be built virtually all out of balsa wood. I mean, if people know how to use the grain of woods and they know how to glue in a couple of different layers of balsa wood, almost like plywood, you can make your hinge mounts out of balsa wood. There's so much you can do if you know what you're doing. And a lot of it's just experimenting and testing. So that's it for this video. It's talking about your systems. It's so important. As we go through these 10 or 12 videos, we're going to incrementally get to the point of where you end up with a design finished at the end. Okay? So we haven't even started drawing in CAD yet. Okay? Next video is going to be about airfoil, and that's all it's going to be is about airfoil. Because there's a lot of misconceptions in model aircraft about airfoils and the importance of them. I'm not talking about gliders here. I'm talking about general sport flying planes here. Gliders, airfoils matter a lot. Most of our RC planes, airfoils are not that important. So thanks for watching the videos, everybody. Sorry for sneezing. My allergies are acting up. You can hear it in my head probably. And I look forward to seeing you the next time. Hope you find these informative and have an awesome day. Take care, everybody.